Coming from a craft background, I'd always made everything by hand, so using files and drills and generally a subtractive mode of fabrication. So when this additive fabrication technology came along, it completely changed the parameters, which was really exciting.
I think one of the interesting things to really understand about the 3D printer is it's closer to the idea of growing something rather than fabricating something.
It's a bit like a tree that uses cellulose and lignin as the two major building blocks, and it has all these functions for bringing water up and down, for creating structure and doing all sorts of things with these very simple materials. And you could do exactly that with this technology.
There was something quite magical about turning a virtual object into a tangible one without actually touching it.
Well, we're clearly in the midst of a transformation in terms of the way that we design, we make, we consume the objects around us. And so for me, this was a really interesting proposition, how this new technology is allowing us to be more experimental.
When I first came across 3D printing, I was finishing my architecture degree, and at that time I was really looking around for new technologies for construction. But then there was this missing link that I saw in the fabrication technologies. When I found 3D printing, it was just like, wow, that's the silver bullet.
Using 3D printing wasn't about the novelty of using 3D printing, it was about seeing what this new technology could do and how it could do something in a way that I couldn't previously do by hand. So the technology that I'm using today is very high resolution, and it's also using a material which is very similar to wax, which can be burnt away in the lost wax casting process or an investment casting process. So it enables me to produce very, very, very detailed fine wax masters, which are then cast into precious metals.
The materials technology really hasn't quite caught up for printing concrete, say. If we didn't 3D print the concrete, we could 3D print the mould. One of the things that I identified about printing wax as a mould, it's a lot cheaper because you're reusing, recycling all of the material, and then you're able to achieve accuracies that you couldn't achieve with normal 3D printing because we mill the surface after it's been 3D printed. So we can print very fast and mill the surface, which really results in a much more efficient way of making moulds.
3D printing has the potential to revolutionise the medical industry. With patient-specific prosthetic components being designed and fabricated, we can provide better treatments for patients with bone cancer, congenital abnormalities or trauma. I first started using 3D printing this year to develop a new 3D printed prosthetic joint replacement here in the School of Engineering at Melbourne University to replace a patient's temporomandibular or jaw joint.
King Cole, which is for the shapeshifters, took 2,000 hours of 3D printing, and then I assemble all the different pieces into the final work. So once it was all put together, I then had to make a silicon mould, and then it's then cast in coal with resin and go through a process that I'm not sure what's going to happen when I pull it out of the mould. So 3D printing for me is not the end stage, which is, I guess, one of the things that I think people think that it's always going to come out perfectly cooked. I'm also going, well, no, I want to change things, and often there's a disconnect between what's in a cyber world and what's in the real world. So I'm always fascinated, like when these objects come back out into the real world via the 3D printer, that you do feel like you need to change them.
Well, I think in the context of this third wave industrial revolution, if you like, it's a call to arms. It's asking us to be actively involved in the making of our world. And it doesn't diminish the role of the designer, it asks us to be involved and support the process of design.